Triangular prism is one where there are two different slopes. You look for the altitude line first. It's inside the triangle, so it's not a real line, it's only imaginary. So that means that the altitude is not building a wall, and you have to look at the edges of the two walls that are not the floor. On this one, it's hard to look at right now because, again, the right angle is not along the horizon. So turn your triangle, turn your paper so you can get the right angle in the right place. And that way you will make sure that you identify the base correctly. So we'll label the base. This is the base. This is a slope because this is a slope. This other one is the slope. So since we have two different slopes, we have to code them. We'll call that one slope 1 and that one slope 2. The distance from this front triangle to the back triangle is right here. So that is our length. And this is our altitude, the imaginary line. So we have all the necessary parts identified. Let's call this slope 10. This slope 3. The length, we'll make it really short. We'll only make it 1 from triangle to triangle. The altitude will make 1. And the base, which is the whole triangle, not just one part, it's the whole line, we'll make that 9. So now we need our formula again. So as usual, the triangles don't change their formula. They're BA over 2, and there's 2 of them. The floor does not change. It's still the length times the base, what it's sitting on. This end wall here is sitting along the slope, and it's slope 2 with the length. So that again is the length, which is always part of the wall. Length times S2 plus the larger slope, which looks like a ramp, is again the length times S1. It doesn't matter which order you put them in, as long as you make sure you're counting every face and not repeating one. So putting our data in, the base is 9, altitude is 1. That's over 2, 1 triangle, length, base times altitude divided by 2, doubled, plus the length of 1 with the base of 9. The length of 1 with the second slope, because we put S2 first, so that's 3. And the last one, that length right here. This is the length on the wall. The length of 1 times S1, which is 10. Okay, third step as usual, calculate. I'm going to cancel those. So 9 times 1 is 9. 9 times 1 is 9. 1 times 3 is 3. So it's nice when there's only one, some dimension's only worth 1. And 1 times 10 is 10. Add them up. 9 and 9 is 18, plus 3 is 21, plus 10 is 31. Again, we'll call these all centimeters. So we have centimeters squared. Just make sure you're looking at the diagram, and whatever dimension is on the diagram is the dimension in your answer. So this is that triangle that has 2 different slopes, and the altitude is inside the triangle. So you need to look at that first.